Alright, here we go, 9.4. It's really just trig graphing again, but the essential question is how do we graph trigonometric word problems with an exclamation point. So that's what that says. How do we graph trigonometric word problems? If you're an absent person, you're probably starting here. Otherwise, you've probably already gotten this in class. So here we go. The tides in a particular bay can be modeled with a sinusoidal equation where t represents the number of hours since high tide and d represents the depth of the water. Alright, so t is the amount of time that's gone by, d is the depth of the water. So that's going to be going up and down as the tide comes in, not the actual waves. Alright, so the maximum depth of the water is, key word here, 36 feet. Min is 22, like red better. And it says that happens at 6 p.m. The minimum depth is 22 feet at 6 p.m. Alright, that's important to know. Alright, on the grid below, graph the scenario for a 24-hour period beginning at 12 noon. Okay, well, we want to have our starter sketch, which I have absolutely zero room for. We always want to start with that. All right, so it's starting at 12 noon. Oh, yep, right there. Yeah, 12 noon, it is at its maximum, so that's good to know. All right, so let's get our graph going. Come on, stupid thing, please work. So, starter sketch. It is starting at high tide. Right, starts at noon, which is the maximum depth. It's going to be up at 36. All right, so we have a maximum at 36. We have a minimum at 22. It told us that. We got to find the middle. So you can just kind of count to the middle. It's your choice, or you can add them up and divide by 2. So if you do 36 plus 20, no, come on, plus 22 and divide by 2, that's going to give you the middle. Works out to be 29. Or you can just kind of look at it and go, I wonder if 30 is the middle. Well, if 30 is the middle, that'd be 6 away from 36, but it'd be 8 away from that. That's not right. Let's go one less. It's your choice how you find the middle. I don't really care. You can do guess and check. All right, but I can see that 29 is 7 away from 22, and it's 7 away from 36. All right, so now we got to plot some points and see what's happening here. It starts at 12 noon, okay? So this guy right here would be 12 noon. All right, and then it says by 6 o'clock, so that's the maximum where it starts. By 6, so we'll put a little mark there. This is 6. It's at its minimum. Okay, so it goes all the way down. So this is kind of a weird question. They make them a little bit more challenging like this. You need to recognize that that is half of a curve. And what curve is that? Well, if it starts at its max and then goes to the min like that, that is a cosine curve. So this is 12 noon that we have here on this side. Here is 6, right? p.m. And now we have to go to the next one, which is going to be way up here. And there is one complete cycle. All right, so it took 12 hours from 12 noon to 12 midnight, 12 a.m. that is, okay, for the one cycle to complete. And there is our sketch. But they want us to graph it over a 24-hour period. So if we see one of them by 12, all right, from 12 to 12, we're going to see two of them in a 24-hour period. So now we're going to take and copy that sketch down to here. And here's the trick. When you are copying that sketch, okay, down, you can't just say, hey, I want that to be 22, right? And then, I want any random spot to be 36. We have to make sure that this is evenly spaced out. So what we're going to do is we're going to use, I like 4 boxes. So here's 22. I'm going to count up 1, 2, 3, 4 boxes, okay, and that's going to be 29. And then I'm going to count up 1, 2, 3, 4 boxes, and that's going to be my 36. Here's the problem, though. This can't be 0 and go 0 just to 22. We need to include what's called a break, and I'm going to do this in blue so you can see it. It just means that whole graph got scrunched down into it. It's a mathematical break. It means that we want to see only between 22 and 36. So we're going to just graph from there, and then we're going to let them know that, hey, we took this whole graph and we scrunched it right down. We scrunched it all down from 0 to 22. It should have been up here. We scrunched it down to this little area because it's insignificant and it doesn't matter. All right, taking too long to do that, I'm sorry. So here we have our 12 noon, so 12 p.m. Okay. We have our 6 p.m. and I'm going to go, let's see, I got to find a space in between, so 6 is halfway point, so I'm going to go 1, 2, 3, and then 1, 2, 3, that'll be 6, 1, 2, 3, 1, 2, 3, that can be 12, all right, a.m. and then I'm going to go 1, 2, 3, 1, 2, 3 for another 6, 1, 2, 3, 1, 2, 3 for another 12. All right. So what we just did there is nice, but it's not what we really need to have for our x-axis. So you see how it says where t represents the number of hours since high tide? Well, this first one at 12 can't be 12 hours since high tide. This is high tide, so this also has to be 0. So I'm going to go over it in red so you know that the red is correct, okay? So this is 0. This is 6 hours since high tide. This is 12 hours since high tide. This is 18 hours since high tide. And this is 24 hours since high tide. And this is our 24-hour period, 0, 6, 12, 18, 24. So from there, I'm just going to plot my points and graph it. So here I have the max. At 6, it's supposed to be at the min, which means exactly halfway it'll be on the line. At 12, it will be at the max again. And then we play connect the dots. And if you only graph this much, you don't get full credit. It's probably a 2-point question on the regions, which stinks. So, got to graph it again. All right, beginning, end. Here is your middle. And then in between, it should be right on the line. And then you play connect the dots. There you go. Here's your y. This is your x-axis because you have 0 there. And you're good to go. Write an equation that models the scenario in degree mode, and then an equivalent equation in radian mode. Okay, so we got to write the equation. So the equation, well, we can first and foremost see that this is a cosine curve, all right? So f of x and f of x. Okay. What is the amplitude of this? Well, how far is it going up and down from the middle? That's this distance here, okay? From 22 to 29 or from 29 to 36 is 7, so it's 7. Cosine. It is a positive cosine curve. Why? Because it starts above the middle line. Okay? So 7 cosine of something x plus or minus the shift. Where is the shift? Well, that's that middle line right here at 29. So the last thing we need to figure out is what is the frequency? Well, the frequency is equal to 2 pi over the period. And you need to know the definition of period. Okay? The definition of period is the length of one cycle. How long is one curve? Well, 2 pi over 12, because that's the length of one curve, is 12 units. So 2 pi over 12 becomes pi over 6. You can totally leave that as 2 pi over 12 if you want to. Just know that on the exam it won't be. So that's radian. All right, now I'm going to do the next one in degree mode, which is all still the same. It's still 7 cosine. It's still something x plus 29, but it's that something x that changes if you're going to be in degree mode. Okay? So in degree mode, we can't use 2 pi. We've got to use 360. So 360 over 12. Well, 360 over 12 is a little bit easier to deal with because you don't have that pi there. So type in the calculator. 360 over 12 is just 30. How nice. Nothing to it. That's a horrible 3. Let me hit back, see if it goes away. Let's try and do the 3 again. There we go. So it's 7 cosine of 30x plus 29. Don't worry about part C. We're going to skip that. I'm going to move on to question 2 and hopefully do that a lot faster. Okay, so here we go. Rochester, New York. In April, the daily low temperature is around 37 and the daily high temperature is usually around 55. The temperature is typically at the daily low at 6 a.m. and the daily high at 6 p.m. Yeah, that was fudged. But we'll go with it. And the highest temperatures are in the afternoon, right? Well, yeah, that makes sense, right? I mean, I guess. So, we got to graph this. On the grid below, graph the scenario described for a 24-hour period beginning at 12 a.m. Notice they gave you 6 and 6 for the low and the high, but yet you're starting at 12. Yeah, that's not fun. So, what are we going to do here? Well, we got to take a look at this. All right, we got to start at 12 a.m. So, let's make our little starter sketch. Maybe I'll put it over here. So, starter sketch. All right, we have our low, we have our high. So, 37 is the low, and 55 is the high. Got to find the middle of that. So add those two up, 37 plus 55 divided by 2. That's supposed to be a 7. And you're going to end up with 46. Okay? You can ask yourself how far apart those are, but they're 9 apart, which works out really well that they're just 9 apart. So we're supposed to start this bad boy at 12 a.m., so I'm going to put a 12 right here at the bottom. And then my tick marks here. It's going to end someplace, but at 6 a.m. it's got to be at the low. And then at 6 p.m. it's got to be at the high. So if this is 6 at the low, a.m., and then this guy right here is 6 p.m., it's the high, you can kind of see what's happening here. I probably should use a different color for that. Let's go with green. So, in between, it's doing this. There's the low to the high. So in that first 6 hours that I have right here, I kind of have to figure out what's going on. That last 6 hours right here, I kind of have to figure out what's going on. Now it looks like this could be a cosine curve, but in reality I only have, in a 6 hour chunk, I'm only doing one of these little quarter arcs. So in this last 6 hour chunk, it's going to end up here. And then in this first 6 hour chunk right here, it's only going to make it to here. And you can see this is a weird way of giving us a sine curve. So let's go ahead and fill in the blanks of what was missing on the starter graph. I am missing the next 12, and then 12 again. Right? 12, 6, 12, 6, 12. And there we go. So now let's make our graph. Get this done. We're going to include a break. Again, we're going to have the middle. That's going to be at, do this in a different color, 46. The minimum is 37. 1, 2, 3, 4. I'm going to include my little break in here. Let everybody know that we scrunched it up. Go 1, 2, 3, 4. It's very important, again, that you keep even spacing in between the 37, the 46, and the 55. Okay? It's also important that you have that break there. That break is very important. There is 0. Okay? So, we want to move along here. We're going to start with 12. And then I'm going to count 3 boxes. 1, 2, 3. Put my 6 a.m. Count 1, 2, 3. Put my 12 p.m. because the first one was a.m. Count 1, 2, 3. This is now going to be 6 p.m. And then 1, 2, 3. We're back to 12 a.m. Sorry. It's tough writing with this stylus. It's not working very well. So we're just going to graph this now. Copy from the starter sketch. So at 46, boom, 12 a.m. All right, by the second 12, we were all the way out here. And then that was the end of one cycle, one 24-hour period. All right, at 12 p.m., midday, it's right in the middle, it's on its way up. At 6 a.m., it was at its lowest. At 6 p.m., it is at its highest. Click connect the dots, and we are good to go. So the next part is write a trigonometric function that models the temperature T in Rochester H hours after midnight. So I guess I did forget to write this would be X and this would be Y. Okay, but now they're changing it anyway. So the temperature T H hours after midnight. So now we're going to have an H here. X is the same as H. Okay, and then this is going to be the temperature T. All right, so we're going to have f of t equals, all right, and what kind of curve is this? Well, this is a sine curve, okay, it is a negative sine curve, so we're going to throw that negative on there, and then we have to have the amplitude, which is the distance between 46 and 55, which is -9, all right, it's in terms of h, so it's not going to be an x there, although typically it would. X and h are the same, you can see it, so it's something x and then there's something h, plus whatever the shift is, which is 46. And that's going to be the exact same equation for sine in degree or in radian mode. So let's put the degree mode first. We'll call this one radian. Even though it didn't ask for both, the first one did, so I might as well do it here. You never know which one you're going to be asked for. And the only difference is it 2 pi over the period, right? Or is the frequency 360 over the period? So 360 over the period, which one is the period? How long did it take to complete one full cycle? So here's where you have to do a little bit of math. You have to realize that this is starting out at 0, this is 6, this is 12, this is going to be 18, and this is going to be 24. So it took how long to complete one full cycle? Well, it took 24. So 360 over 24. 360 over 24 works out to be 15. It's going to be 15h. And then if it's 2 pi over 24. That works out to be pi over 12. Or you can leave it as 2 pi over 24. And you're good. That's it. Part C we're going to skip, so don't worry about that, okay? Typically it's done in the calculator, and we're just not going to jump to doing that stuff in the calculator yet. Don't forget to write your summary and get your practice done in class. Thank you.